final activity and having fun with chemical formulas. I hope you've been successful with the word equations and the chemical equations, and we're going to be using those skills in this last activity looking at balancing chemical equations. This is by far the hardest skill that you'll face in this course, and probably in most of your middle to high school chemistry careers. Once you've got this under your belt, you'll find that going on to senior chemistry a whole lot easier. So let's get on and let's look at how we balance equations. Now I'm going to deal with this in two main areas. The first one we call balancing equations. Number one, we're going to look at how we go through the basic skills. And then in balancing equations number two, the example we're going to work through is a little bit more complicated. This is one where they don't balance. So what do we do? The first thing that we need to do with any reaction that we're looking at, whether it be as a practical or from a question scenario, is to write down the word equation. Then we need to write down the chemical formula for each of the words. And then we start getting into the nitty-gritty of the balancing equations. Now the first thing that we need to work on is to identify that we've got the same atoms at the beginning as we've got at the end. So firstly, look on the reactant side of the equation and just identify all the various atoms. Then look on the products and do the same for that. They should be the same. Remember, in a reaction you never create new atoms, or at least at this level you never create new atoms. So once we've identified the atoms, the thing that we then need to look at is how many of the atoms have we got on the left hand side and how many have we got on the right hand side. It's like, you need to think of it like baking a cake. When you bake a cake, you put in your flour, your eggs, your sugar, your milk. Then you bake your cake. Your cake is your product. The amount of flour that you put into the batter is exactly what's inside the cake. The number of eggs that you put in the beginning is exactly what's inside the cake. So you've not lost anything, but you've just reconfigured them. And that's the one thing that you need to understand. Now the other thing that's worth noting before we start is that the chemical formula, once you've written down the chemical formula, it never changes. Don't touch it. That is the major rule. Don't touch the chemical formula. The chemical formula is the name, the chemical name of the compound. You never change your name by adding an extra letter, so likewise we shouldn't do that with the chemical compounds. If you follow that rule, you won't go wrong. Okay, so let's have a look at a wee example which is going to sort of briefly explain what's going on. So here I've got a seesaw. Now the seesaw, as you can see, is balanced. Now on the left hand side we're going to put all our reactants, and on our right hand side we're going to put our products. So let's put some compounds. Now the compounds on the reactants are going to be made up of red blocks, green blocks and orange blocks. So we've got three compounds which we're going to join together, and they go to form two compounds. We've got one where it's got two red blocks and a green block, and we've got one where we've got a green, a red and an orange. So there's two compounds joined there. So the first thing that we need to do is to identify the types of atoms and the number of atoms we've got. Well, let's look on the left hand side. On the reactant side we've got three red atoms. So the red atoms are the type of atoms, and the three obviously is the number. We've also got two green atoms. We've got one orange atom. Now let's look on the right hand side, on the product side. You can see that on the product side the types of atoms we've got are red atoms, and we've got three of them. We've also got green atoms, and we've got two of them, and we've got orange atoms, and we've got one of them. Now just by looking at that we can say that because they're the same type and same number on both sides of the equation, the reaction is balanced. Okay, so let's put that into practice. So in this example we're going to do a neutralization reaction where we're using sodium hydroxide, which is reacted with hydrochloric acid, and it makes the solution sodium chloride and water. And we're going to write our balanced chemical equation. So the first thing is to write down our word equation. So there we go. Then we write down our chemical equation. NaOH plus HCl gives us NaCl plus H2O. Hopefully that should be no problem for you. So make sure that you fill in the gaps as you run through this with activity 12, filling in the red lines as you go through. What is also probably useful is as we go through this, if you pause the video, you can then try it for yourself and then fill it in or go the other way. It's entirely up to you. Okay, so now we've got our chemical formula. So this is where we now start needing to do the final bit where we identify the atoms. So you can see here I've filled in two columns on both sides. One is the atom type and one is the atom number. So let's look through the reactants and see what atoms have we got. Well, we've got sodium, Na. We've got an oxygen, we've got hydrogens, and we've got chlorines. Notice I'm just putting down the atoms. I'm not saying how many atoms or where are they. I'm just saying what have we got on the left-hand side. Then I'm going to look on the right-hand side. Let's look at the products. Well, we've got some sodium, we've got some chlorine, we've got hydrogens, and we've got oxygens. So looking at the two columns, you can see, hey, they're identical. We haven't gained or lost any of our atoms. That's great. So the next thing we need to do is then look at the number. How many atoms have we got on each side of the arrow? Okay, so let's look at sodium. We've got one sodium. That's shown in the red circle. How many oxygens have we got? The blue circle. We've got one of them. How many hydrogens? These are going to be in green. Well, we've got one hydrogen on the sodium hydroxide and we've got one hydrogen on the hydrochloric acid. So we've got two hydrogens. And finally, how many chlorines have we got? The purple circle. We've got one of them. Great, okay. So remember, we're going to try and balance them on the product side. They should be equal on the product side. So how many sodiums have we got? We've got one. How many chlorines have we got? Oxygens we've got one again. How many hydrogens? We've got two. Now if you look, it says H2. That means there are two hydrogens joined to the oxygen. So I must include that. So if I had another hydrogen, let's say with the NaCl, it doesn't work like that, but let's say it would be 3, so I'd add it all together. And finally, we've got one chlorine. Now if you look at the atom types and you look at the atom numbers, you can see they're bang on, they're equal. So I leave the formula as is and just write it down. Okay, so that's easy. That works on just running through the skills of identifying the atoms we've got and then the numbers. So what happens if they don't balance? Okay, well the key to doing that, we need to increase a number of atoms on one side. We place a number at the front of the chemical. Now placing it at the front of the chemical means it's 1, 2, 3, lots of that chemical. Remember the chemical symbol, the chemical formula does not change. So we just say we have 2 lots of this added to 1 lot of that. It's like a ratio. Hey, you do that when you make a cake. You might add 2 cups of flour to 1 cup of sugar, and it's a ratio. It's still got sugar, and you've still got flour, but you've got 2 lots of the flour to 1 lot of the sugar. Okay, well let's have another look at an example, and hopefully it will make more sense. So here's our seesaw again. We're going to add to it our 3 reactants. We've got our 3 reactants where we've got our red bricks, our green bricks, and our orange bricks. However, when we put it together on the next side, we get a reaction which gives us products where they've sort of multiplied. Okay, now we don't need to know it at this stage how. We're just going to try and balance it. So let's just look at what we've got. Well, on the left-hand side, we've got 3 lots of red atoms, 2 lots of green atoms, 1 lot of orange atoms. But on the right-hand side, we've got 6 lots of red atoms, 6 lots of green atoms, 1 lot of orange atoms. Okay, now straight away, you can see that the type of atoms are correct, but the numbers are not. They're what we call not balanced. So we now need to balance it. Okay. So the question then is, what have I got to do to the left-hand side to make the right-hand side equal? What have I got to do to 3 bricks, 3 red bricks, to turn it into 6 red bricks? Well, I need 2 lots of it. 2 lots of 3 lots of bricks makes 6 lots of bricks. Okay, I've got 6 green atoms on the right-hand side. What have I got to do to the left-hand side to the green atoms to make sure I've got 6 lots on the right-hand side? Well, I need 3 lots of green atoms. Great. Now, if we look at the orange atoms, I've got the same number of orange atoms on the left-hand side as I've got on the right-hand side, so I don't need to change them. So when I write this down as a formula, this is what it looks like. I've got 2 lots of the red bricks plus 3 lots of the green bricks plus 1 lot of the orange bricks. Notice we never put the 1 at the front of it. And that will give us 6 red bricks, 6 green bricks and 1 orange brick. I hope that sort of makes sense. Okay, because they're equal on both sides, we can now say that the equation is balanced. So let's look at another example and I'll show you how we work that through. And if you come back and look at this bit, then probably it will make more sense. Okay, so here's an example that we've already looked at, but it's magnesium metal joined with hydrochloric acid and it produces hydrogen gas and magnesium chloride. So the first rules, as we stated, is to write down the word equation, and then we're going to write down our chemical equation. Okay, might be a good place to pause, fill in the missing gaps, and that will be good. And then when we go on to the next slide, we'll run through the process as to how it works. Okay, so let's look at this process. So the first thing that we need to do is to run through the different types of atoms that we've got. So there's our 2 columns, atom type and atom number. So we've got magnesium, hydrogen and chlorine on the left hand side, and on the right hand side we've got hydrogen, magnesium and chlorine and nothing else. Okay, the atom types match on both sides. Brilliant, good start. Now what we're going to do is to add up the number of atoms we've got on each side. So for magnesium, which is going to be shown in red, we've got 1 atom. For hydrogen, in green, we've got 1 atom, and in chlorine, in purple, we've got 1 atom. Okay, so let's look on the right hand side. So we start off, magnesium, we've got 1 of them. Hydrogen, now look, it says H2, so we've got 2 hydrogens there. And chlorine, Cl2, so we've got 2 chlorines. Now straight away we can see that they don't match. So what bits, the next thing we need to do is determine which bits don't match. Well, the hydrogen and the chlorine don't match on the left hand side. So I've got to do something on the left hand side to turn those 1s into 2. Well, the way in which we do it is by putting a number at the front of the compound. Now the number we're going to put to convert 1 into 2 is the number 2. If I do that now, I've now got, it means 2 lots of HCl, so I've got 2 hydrogens and I've got 2 chlorines. Now by looking at that, the equation is now balanced. The left hand side is the same as the right hand side. So the overall formula is Mg plus 2 HCl gives us H2 plus MgCl2. Basically, in order to get the reaction to work, I need 2 lots of hydrochloric acid to join with 1 lot of magnesium. Okay, I hope that makes sense. I know it's complicated and it may require you to run through it a couple of times just to clarify things. But if you feel confident, have a go now at activity 12, and thank you for watching and good luck.